Welcome to another session of basic mathematical analysis. Today we are going to deal about contractive sequences. First of all, we will examine what is the definition of a contractive sequence, and after that we will move to one interesting example and one theorem. The theorem says that every contractive sequence is a Cauchy sequence, hence it should be converges. Definition: we say that a sequence x equal to xn of real numbers is contractive if there exists a constant c lying between 0 and 1 such that xn plus 2 minus xn plus 1 is less than or equal to c into modulus of xn plus 1 minus xn for all n belongs to n. The number c is called the constant of the contractive sequence. That means, suppose you have got a sequence, your sequence xn is equal to x1, x2, x3, x4, etc. And I'm finding here one number xn, next number xn plus 1, next number xn plus 2. And sorry, etc. Right? Sequence. So, etc. So this is my sequence. Now, when I'm finding the distance between, if I'm representing this in a straight line or in real line, this is my xn, this is xn, x4, x3, x2, xn. Now, the distance between xn plus 2 and xn plus 1, that's the meaning of this, right? Modulus of xn plus 2 minus xn plus 1. So this distance, right? This is some c times what is xn plus 1 minus xn. Modulus of that means this distance, right? Now this distance should be a multiple of this distance, and that multiple number c. So if I'm mentioning this as d1 and this as d2, my d1 should be some c times d2. Now what is the speciality of this c? C should lie between 0 less than C less than 1. So I can have the value C equal to 1 by 2. Then what should be our D1? D1 should be half of D2. Right? Now next element. So I am finding next element. I am fixing C equal to 1 by 2 means what I will get? C equal to 1 by 2 if I am fixing. So I will get these distances are decreasing, right? Can you follow? So I will get my x2 minus x1, right? Or x2 minus x3 minus x2. This should be half into this one. That means half of this. Now if I am finding x4 minus x3, it should be half of this distance, right? So if I am fixing that equal to 1 by 2, what I will get is, suppose I am starting with here x1, here x2, here x3, and here x4, then x3 minus x4. Suppose I am fixing this distance as d. Now what should be this distance? This means d by 2, right? Now this distance, this by 2, so d by 4 will come. So like that it should. So I think you may have an idea about what is contractive sequence. Contractive in the sense, see here, it is going like a compressive way. So we will say that this is a contractive sequence, and this number c is called a constant of the contractive sequence. Now we will have a theorem. Every contractive sequence is a Cauchy sequence. So what we want to prove? We want to take a contractive sequence, that means a sequence which will satisfy this one, this idea. Then we want to show that it's a Cauchy sequence. Cauchy sequence means, Cauchy sequence we are having the idea that modulus of xm minus xn is less than epsilon for every n comma m greater than or equal to some k, right? So after assuming this condition, we want to show that this also holds. So first of all, we are having a contractive sequence. So that contractive sequence, I can go on applying our this condition, right? So when I am dealing here, modulus of x n plus 2 minus xn plus 1, I will get c into modulus of xn plus 1 minus xn. Again, I am applying this one. So xn plus 1 minus xn. This should be again less than or equal to c into modulus of xn minus xn minus 1. Right? So therefore, what I am having is modulus of xn plus 2 minus xn plus 1, which is less than or equal to c into this. Now this will become c into this. That is c square into uh, modulus of xn minus xn plus 1. So this we can have. Now suppose I am applying this condition repeatedly, what will happen? So I will get next term some c cube into modulus of xn minus 1 minus xn minus 2. Now this is less than or equal to, next term will come c raised to 4 into xn minus 2 minus xn minus 3. So like that, if I am going, the last term should be x2 minus x1. So I will get less than or equal to c raised to n into modulus of x2 minus x1. Now I want to check the Cauchy sequence idea, right? So I'm taking an m greater than n and I'm finding what is xn minus xn. What this should be. That is the next stage we are going to find. See, I can write this modulus of xn minus xm is less than or equal to modulus of xm minus xn, that's equal to modulus of, I can have xm minus xm minus 1 plus xm minus 1 plus xm minus 2, sorry, minus, I should take it as minus xm minus xm minus 2 plus xm minus 2 minus xm minus 3 plus xm minus 3, right? Plus etc. Last time should be xn plus 1 minus xn, modulus of this. Now if I am splitting this, okay, I can have like this. Now what I should do, I can apply triangle inequality. So I will get this is less than or equal to this. That is, this one follows from triangle inequality. So I will get this is less than or equal to xm minus xm minus 1 plus xm minus 1 minus xm minus 2 plus etc. plus modulus of xn plus 1 minus xn. Now applying our contractive sequence idea, that is this one. See this one. So I'm putting this as star. Now from this star we can have our first term. First term is xm minus xm minus 1. So that should be less than or equal to, see here, what's coming? Xn plus 2 minus xn plus 1 I am taking. It is coming as c raised to n. that is first index minus 2. So here I should take m minus 2. So it will come c raised to m minus 2. Next term, m minus 1 is there, so minus 2 I should have. So c raised to m minus 3. So like that. Now what is this one? C raised to m. This is c raised to m minus 1 plus c raised to m minus 3 plus c raised to m minus 4, right? Minus 2, right? 4 plus etc. c raised to n minus 1. Will it form a geometric progression with what is common ratio? So it's a GP, geometric progression with common ratio. What's common ratio? With a common ratio, minus 2 become c raised to minus 1 or 1 by c, right? So this is a geometric progression with common ratio 1 by c. So this will form sum of how many terms are there? How many terms? M minus n minus 2 terms, right? So this much of terms. So it will form the sum of first n terms of a geometric progression by using the idea a into or a n into 1 minus r raised to n plus 1 by 1 minus r, we will get this is nothing but geometric progressions sums, right? So c n minus 1 into 1 minus c raised to m minus n minus 1 plus 1 will come. So that will become m minus n by 1 minus c into modulus of x2 minus x1. Now this can compare with, this is a finite terms, so an infinite geometric progression, right? This we have compared with infinite terms. And this is converges because it's given that c value, right? C value is lying in between 0 and 1, right? So here it will reduces as c raised to 1. This we know that first term is 1 by 1 minus r type, right? So c raised to 1 n minus 1 into 1 by 1 minus c into modulus of x2 minus x1. Now what about this sequence cn minus 1? Since our c value is lying between 0 and 1, limit of c raised to n is equal to 0. This we have already seen. So this quantity is converges to 0. So that means whenever your n value is getting bigger and bigger, this this side will reduces to 0. Implies? So this implies when your n value tends to, or n or tends to is not suitable. So when n is sufficiently large, then the same putting as double star, right? Then RHS of double star reduces to 0. So this implies there exists some k belongs to n sufficiently large number such that your modulus of, you have taken xn minus xm, right? Xm minus xn is less than some epsilon for m comma n greater than or equal to this k value. So this implies that the sequence is Cauchy sequence. This implies our sequence xn is a Cauchy sequence. And by Cauchy criteria, this implies, since every Cauchy sequence is converges, which implies Xn converges. This implies your Xn converges. So, which implies, hence, a contractive sequence, hence a contractive sequence is a Cauchy sequence. So hope you understood the proof. So we have proved that the Cauchy sequence, a contractive sequence is a Cauchy sequence. Next we will have an example. This is called Fibonacci fractions. You know what is Fibonacci sequence and all. And using this Fibonacci sequence, we are forming Fibonacci fractions. It's nothing but xn is defined as fn by fn plus 1. Right, where f1 and f2 are given to be as 1 and fn plus 1 equal to fn plus fn minus 1, nothing but Fibonacci, right? Fibonacci sequence. Now, the first few terms of the sequence, if you're writing, it should be 1, 1 by 2, 2 by 3, 3 by 5, 5 by 8. That is, our sequence is nothing but xn equal to 1, 1 by 2, next term 2 by 3, next term 3 by 4, 3 by 5, next term 5 by 8, etc. Right? Follows from your Fibonacci sequence. What is Fibonacci sequence? 1, 1, next value 1 plus 1, 2, next value 3, next value 5, next value 8, next value 8 plus 5, 13, etc. Right? Now, according to this, your first term is x1 is going to be f1 by fn plus 1. That's 1 by 1. So, first term is 1. Second term, fn by fn plus 1. So, second term, 1 by 2. Third term, 2 by 3. Next term, 3 by 5. Next term, 5 by 8. Next term, 8 by 13, like that is going. So this is our sequence here. Now the nth term of the sequence, if you're finding the nth term, what should be the nth term? See here, nth term is defined as fn plus 1 by fn plus 2. That's equal to fn plus 1 by fn plus 2 can be written as fn plus 1 plus fn, since it is a Fibonacci sequence, right? So now dividing both numerator and denominator with fn plus 1, you will get fn plus 1 by fn plus 1. That will reduce as 1. And here fn plus 1 plus fn all divided by fn plus 1. So fn plus 1 by fn plus 1, that is 1 plus fn by fn plus 1. So it will reduce as like this. Now this term is our nth term. So it will reduce as xn plus 1 equal to 1 by 1 plus xn. So the general term is going to be xn plus 1 equal to 1 by 1 plus xn. Now, by using induction, we can see that these all values lie between 1 by 2 and 1. All these values lie between 1 by 2 and 1. See here, your first value is 1, second value is 1 by 2, third value is 2 by 3, less than this, right? 3 by 5, again less. Next value 5 by 8, next value 8 by 13. So every value is coming in between 1 by 2 and 1. We can use this by induction method to prove this value. So I'm leaving that for you to work. So you use the induction method to prove that your nth term of the sequence always lies between 1 by 2 and 1 for all n values. So that adding 1, that means if you are adding 1 to this, then also 1 by 2 less than or equal to xn plus 1 less than or equal to, you get this as 1 plus 1 you get, right? Then, and taking reciprocals, we will get 1 by 2 less than or equal to 1 by 1 plus xn, which is less than or equal to 2 by 3. We will make use this idea here, that is this part. That is 1 by 1 plus xn is less than or equal to 2 by 3. Okay, so for that, what you have to do? First, we will consider what is xn plus 1 minus xn, Cauchy sequence. Okay, we want to check whether it will form a Cauchy sequence or not, and whether it's a contractive sequence or not, right? So we're taking xn plus 1 minus xn. So xn plus 1 minus xn is equal to, to write this as using formula. And what is xn plus 1? Xn plus 1 from here it is 1 by 1 plus xn minus, what is xn? What is xn? That is 1 by 1 plus xn minus 1, right? Take LCM, what do you get? 1 plus xn minus 1 minus of 1 plus xn whole divided by 1 plus xn into 1 plus xn minus 1, right? So when you're taking modulus of this, modulus of this, modulus of xn plus 1 minus xn, that should be equal to modulus of this, and that should be equal to modulus of this. Now this is nothing but 1 plus xn values are going to be positive, so you can take this as modulus of, expanding this, you'll get modulus of xn minus 1 minus xn. So when you're taking modulus, you can go in another way also, xn minus 1, right? Divided by, I will get 1 plus xn into 1 minus xn minus 1. Now what is 1 by 1 plus xn? See here, it's less than 2 by 3. So I can replace these two values with 2 by 3. So this quantity will become 2 by 3 into 2 by 3 into modulus of xn minus xn minus 1. Now this is as 4 by 9 into modulus of xn minus xn minus 1. Now take this value, will it lie between 0 and 1? Definitely, right? 4 by 9. So it will definitely lie between 0 and 1. Now the sequence, what you got is, this is true for every n. So hence the sequence is a contractive sequence. So hence the sequence is a contractive. And we can use the previous theorem to show that it is converges, right? So therefore it will converges. So this sequence converges. Now, when you're finding the limit of this sequence, we will get an interesting result. We will say that golden ratio, right? So, limit of x equal to xn, if you're finding, we will get, definitely this limit will satisfy the equation x equal to 1 plus 1, 1 by 1 plus x, because we are finding xn plus 1 equal to 1 by 1 plus xn. So when you are applying limit, this limit and this xn limit both should be the same, right? So it should satisfy x equal to 1 by 1 plus x. when you're cross multiplying this, you'll get x into 1 plus x equal to 1. You'll get a quadratic equation, right? So that equation is x square plus 1 minus 1 equal to 0. So our limits should satisfy this condition. Now using quadratic equation idea, you'll get what should be the root of this equation. We know that x square plus x minus 1 this equal to 0. So root is x equal to minus b. So minus 1 plus or minus square root of b square, that is 1 minus 4 into a is 1, c is minus 1 by 2 into, we get 2 into a, right? So that is 1. Now this would reduce as minus 1 plus or minus square root of 1 plus 4 by 2. So that is minus 1 plus or minus root 2 by, sorry, root 5 all divided by 2, right? So it is plus or minus is coming here. So I have taken the positive solution. So positive solution means I should get this value greater than 1, right? So when I am taking minus value, it should entirely become a minus 1. So I have taken the positive solution. So it is x equal to minus 1 plus root 5 all divided by 2, and its value is going to be 0.618034. This is not the Walden ratio, but when you are taking the reciprocal of this, means it will reduce as 1.618034, etc. Now, this ratio is often called the golden ratio, right? The golden ratio, we have studied this in many classes. What's the importance of golden ratio and what is most of the beautiful or the aesthetic sense of objects lies very close connection with golden ratio. Okay, so with this I'm winding up today's session here. So in today's class we have seen only uh, what is a contractive sequence, and we have proved that a contractive sequence is a Cauchy sequence and therefore it converges. And next we have seen an example of Fibonacci fractions and seen that it's a contractive sequence and it converges, and finding its limit and finding its reciprocal will reduce us to a interesting fact that the reciprocal of limit of the sequence will be the golden ratio. So thank you for your patient listening. Thank you.